Hey guys, today in this video we'll be learning about the last chapter in the C++ programming language, that is templates. So in this chapter templates we'll be learning about the templates introduction and later templates examples, and we'll see the syntax for the template, and we'll also execute a sample program, okay, a simple program on template in order to understand the template in better language, in a better way. And we'll also see the advantages of templates, and we'll also see the need of templates, and we'll also see the classification of these templates. Okay, so majorly this templates is being classified into two types, that is function templates and class templates. And later we'll see about the function templates, and briefly we'll also see about the function templates and the syntax of the function template, and also an example program on the function template with single and multiple arguments. Okay, and later we'll see about the class templates and syntax on class template, and example program with single and multiple arguments, same like function template. Okay, and later we'll at last in this chapter, the last topic is stack data structure using class template. Okay, we'll be discussing about the stack data structure using class template. This topic is very important. It will come for examination for mandatorily. This is very important. This comes for examination for 5 marks. Maybe there is a chance that it will come for 8 marks also, 8 marks as well. Okay, so we need to understand this concept very. This is very important. Okay, so the overview of this chapter is what are templates and what are the need of templates. So we'll be understanding these questions one by one. Okay, first of all, what are templates? Okay, so a template is a kind of pattern. Okay, a template is a kind of pattern or mold. So it is a kind of pattern that is used as a guide for solving a program. For example, if you see in your real life example, a ruler. Okay, a ruler is a template. If you want to draw a straight line, okay, if you want to draw a straight line with the help of freehand, with the help of free line, if you draw the straight line, that will not be an accurate one. Okay, if you use the help of ruler, scale, that ruler, that straight line will be very accurate. Okay, so what is helpful here? A ruler is very helpful in order to draw the straight line. So a ruler is nothing but it is a kind of template that is helping you to draw the straight line. Okay, so in the same manner, in programs also, in order to get some output, we are using the help of these templates. Templates are nothing but the logic functions, okay, logic codes, okay, which contain some important stuff, okay, important stuff, and which deals with all kinds of data types. Okay, so these templates are very useful in order to write any software program. Okay, so I'll tell you the importance of these templates as well, and I'll tell you what are these templates as well. Okay, so in programming language, a template is a generic class or other unit of source code that can be used as a basic for unique units of code. So template deals with the generic programming. Okay, generic programming, this comes for 1 mark. Generic programming, what is meant by generic programming? So generic programming is nothing but which allows the programmers to deal with the different kinds of data types. Okay, different kinds of data types, which allows the programmer to deal with the different kinds of data types in a program. Okay, so these templates are nothing but these templates are declared before the main function, which deals with the different kinds of data types. Okay, so these data types can be passed as a parameter to this template. Okay, these data types are passed as a parameter to this data type and achieves the output, successful output. So the main concept of using this template is nothing but, so the simple idea is to pass the data type as a parameter, so that we do not need to write same code for different data types. Okay, so instead of writing the logic codes for data type separately for the each data type, we are writing the one logic code before the main function in the template, and we are passing the data type as a parameter every time, and getting the output because of the logic function declared in the template. Okay, so we will be seeing the syntax of the template, so that we could understand the templates very easily. So before that, we'll actually know the advantages and all this theoretical stuff about this theoretical part about this theory part about this template. Okay, so templates are powerful features of C++ which allows you to write with the generic programs. So I already told you the generic programming, so which it deals with all kinds of data types, different kinds of data types. So in simpler times, you can in simpler terms you can create a single function or a class to work with the different data types using templates. Templates are often used often used in larger code base for the purpose of code reusability and flexibility of the program. Okay, so instead of writing the larger codes, you can divide them as, I mean, you can make them as you can fragment them, and you can use them as templates. Okay, so for example, a software company need different sort may need to sort for different types of data types. Rather than writing and maintaining the different kinds of multiple codes, they just write one sort of code and pass the data type as parameter. Okay, so in C++, it adds C++ adds two new keywords to support the templates. That is the word template and the type name. Later, this type name is replaced by the keyword called class. Okay, so you actually need to remember and note that you make a note that this word this keyword called class is entirely different from the classes we use. Classes, I mean, class body, right? So those class bodies are entirely different from this keyword class. Okay, hope you understand, and don't be get confused by this keyword class and class bodies. Okay, so that will make you hectic stuff like confusion. We'll understand this templates. First of all, we'll see the syntax of this template, and we'll we'll see a program on this template first of all. Okay, so what is the syntax of the template? So we'll see the advantages of templates first. So what are the advantages of using these templates? So templates use it, and what is the main reason? What is the main reason of using these templates? So it enables the introduction of generic programming. As I already told you, it deals with the different kinds of data types. So it enables the introduction of the generic programming. Okay, generic programming is very, very important in order to design any software, in order to make something else, in order to make any games. Okay, so these generic programs deals with those kinds of things. Templates are very, very helpful for for the purpose of security. Okay, it reduces the size of the program as well and saves the programmer's effort and as well as time, and also it facilitates the further development of the program. Okay, so templates provides the advantages of macros, and another advantages is it is safety. Okay, so and also when it comes to less it is also less redundancy, and it also reduces the programmer's effort. Okay, the implementation of the templates in C++ drastically reduces the programmer's effort. Okay, and reusability and flexibility as well. Okay, we can use the same kind of code whenever we want. Okay, now utility. When it comes to utility, templates are of high utility when it combines with the function overloading and as well as multiple inheritance concept. Okay, so now we'll see the templates of the syntax, and as well as the uh, program on the template. Okay, now need of templates. See, template is a technique that actually allows using a single function or class to work with the different data types. Using templates, we can create a single function that can process any type of data. Okay, that is the formal arguments of template functions or of a template generic data type. Okay, they can accept the data of any type such as int, float, long, double, char, etc., etc. Thus, a single function can be used to accept the values of different data types. So that is the main concept of using this template. Okay, a template safely overcomes all these drawbacks of overloading functions, and templates provide better flexibility to the program, and the program provided by the template mechanism can be extended to any classes. Okay, so first of all, uh, we'll see the templates. Yeah, template, I mean, the syntax of the template, and we'll also execute one program so that you could understand the template concept in a better way. Okay, so we'll see the syntax of the template first of all. Okay, so syntax for the template. Yeah, now template is this is a template is a keyword. So this is a keyword which is basic thing you actually require this word template in order to declare any template. Okay, so and less than and class T. Okay, this class is the main second keyword. This class is not same as class body. Okay, you should actually remember that. And this T is as a T works as a parameter. Every time this T works as a parameter when you are passing the data type as a data type as a parameter. Okay, now we need to declare any function. Okay, for example, I'm taking T large. Okay, T large. So in this, I'm taking the T and one number and two number two. Okay, and I'm writing the main logic function, just a concept of if n1 is less than n2 or n1 is greater than n2. Okay, then return the value of n1. Okay, now in else condition, I'm just writing return the value of n2. Okay, if n1 is smaller than the n2, just return the value of n2. Okay, so outside this we'll declare the main function. Okay, we'll declare the main function. So yeah, before this we'll write the header files, and after the header files we'll be writing this template. And this is the main keyword called template. Must and should we need to write that word template. So these are the header files: hash include iostream.h, hash include conio.h, and using namespace. Yeah, now see, this hash include iostream contains the main keywords called cin and cout. Okay, so some basic reserved keys called cin and cout, and this hash include conio.h contains some main functions like getch and clrsch functions. Okay, now using namespace std, so this is the template and this is a class, and we have declared the we have declared, and this T works as a parameter. Okay, every time we will be declaring different kinds of data types here, and these data types will be passed as a parameter, and every time it will check this condition and it will return the values. Okay, let me give you let me write a simple program in order to understand the templates concept. Okay, so this is a we'll write a program we'll write a program in order to print the smaller number. Okay, in each and every data type: int data type, float data type, and character data type. The main concept of the template is it deals with the generic programming. As I already said you, it deals with the generic programming, right? So we'll see this, we'll find the smallest number in each data type. Okay, first of all, the files. Yeah, complete. Now using namespace std. Yeah, now declaration of template class T. Now we'll declare one function called T small. Just take the values as n1 and n2, accept them. And now I'm writing the main logic function, that is if n1 is smaller than n2, then return the value, just return the value of n1. Or else, if this condition is not true, else return the value of n2. Now we will be declaring the main function. So in main function we'll be giving the different data types: int i1 comma i2, now float f1 comma f2, and character c1 comma c2. Now we'll take the inputs from the user type, your user end. Okay, so enter to integer values from user end. Now we have to read those values, right? I1 and I2. Successfully done. Now we'll declare. Now we will find the smallest one with the help of template. Okay, I'll explain you the program detailedly after writing this program. Okay, don't worry. Now we'll declare the smallest value and we'll print out that thing as a smaller one, smaller, and end the line. Yeah, done. Now next we'll go for the float type. Enter to float values. Yeah, and see in f1 comma f2, I mean f1 and f2, and see out small, compare f1 and f2, and whatever thing that is smaller in between them, just print them as is smaller, and end the line. And we'll at the same time we'll do it for character values as well. Enter to char values. Okay, now we'll read them. Scene C1, C2, sorry, C1, C2. Now we'll print with the help of function template function. I mean function template we declared in the beginning. C1 comma C2, and we'll print that one is smaller. After checking, something will be coming as output, right? So that is smaller, and end the line and return the values. Okay, return 0. Now we'll compile this and we'll execute the program. So let me explain you this one. So first of all, we are declaring the template here. Okay, in this template. So we are writing the template function, a small template function with the help of a single argument, that is class T. And here we have taken different kinds of int, float, char data type, right? I mean data types, right? So every time to write the logic function, you see this is the simple logic function. So this is a simple logic function. Every time, instead of writing this logic function again and again to the each data type, so we are writing at a one at a time, one time before the main function, and we are passing each data type. See, one time will be passing this int as a data type to this template. And see, in int data type there are I1 and I2, right? So I1 and I2 will be N1 and N2 one time. Okay, the condition one. Okay, condition one, I1 and I2 will be N1 and N2. So int small. Okay, so first of all, integer data type will be entering into this template. I mean compiler internally generates all these things. Okay, internally generates all these things, and it will check integer small, int N1 and I2. In int I1 and I2, which one is smaller? If I1 is smaller than N2, then return the value of I1, else return the value of I2. Okay, so this logic will be generated by the compiler internally. It will not show us. Okay, now next, after declaring the integer small value, it will go for the float value. Okay, now float small, f1 and f2. Okay, float f1 and float f2. So if float f1 is smaller than the f2, then return the value of f1, else return the value of f2. Okay, then next it will again happen the same thing simultaneously. It will happen to all these three data types we have, because we have declared three data types and one class, I mean one template, right? So every time the data types, all these data types will be passed as a parameter to this template, and it will execute this function, and it will execute this function, and later returns the smaller value. Okay, and later returns the result. Okay, with the help of this function we have taken the small function, right? So this, we have declared the small function. So with the help of this keyword, we are solving this problem. So now we'll compile this and we'll see the result. Yeah, now first of all, it will asking us to enter the two integer values, now 10 and 20. So the compiler will internally generate, I have already told you, right? The compiler will internally generate. So now I1 is 10 and I2 is 20. Okay, now whatever the smaller thing, so it will go into this template. Okay, so now I1 is smaller than the I2, right? So I1 is smaller than I2. So print that, return N1. So what is N1 here? N1 is nothing but I1. Okay, N1 is nothing but I1. So I1 will be the smaller one. So I1 is what? 10. So 10 is the smaller. So it will again happen to the float values as well. So what is float value I'm going to take here? 10.5 and 20.5. Okay, so between these two numbers 10.5 is smaller. Okay, so same kind of logic will be happening here also. So float data type will be passing as a parameter here to the template, and so float f1 is nothing but 10.5 and f2 is nothing but 20.5. Okay, so 10.5, 20.5, what is the greater one? So 20.5 is the greater one, so the smallest one is 10.5. So it will stop here only. Okay, it will stop here only, it will not go into this else condition. So if we got the 10.5 is the smaller one, so that is why it will stop here itself. Now we'll see two character values, b and a. B and a, so in b and a, what is the smallest character? A is the smallest character here. So we have declared the b, I mean the greater value in front, I mean first time. Okay, before the a value only we have declared the greater value, that is b. Okay, so but here a is not greater than the b, so it will go into the else condition, that is return n2. So what is n2 here? A value is the n2 here. So when character data type is passed here as a parameter, the a value, I mean the n2 value is a and n1 is value is b. So n1 and n2 values are compared. Okay, nothing but c1 and c2 values are compared here. So between them c2 is smaller than the c1, so c2 is printed, that is as a small. So this is a basic program. So this is a basic program on templates in order to understand the templates function, I mean templates concept. Okay, so I hope you have understood the templates program. So మీకు ఇంకా ఈజీగా చెప్పాలంటే let me take one example here. Okay, so two HTML files తీసుకున్నాం ఇక్కడ. Okay, two HTML documents తీసుకున్నాం. Okay, that is linked with the one kind of common CSS file. Okay, one kind of common CSS file. So in that CSS file I have given the color for one div section, that is aqua. Okay, so దీంట్లో ఒక text ఉంది. What is that? Hi, this is sample text. Okay, in order to understand the in order to understand the template in the C++ program, this is just a simple example. Okay, example గా చెప్తున్నాను, this is not the main thing here, but మీకు అండర్స్టాండ్ అవడం కోసం జస్ట్ సింపుల్ థింగ్ చెప్తున్నాను to make it clear. Okay, so మీకు ఇది ఇంటే ఈజీగా అర్థమైపోతుంది వాట్ ఈస్ టెంప్లేట్ అండ్ వాట్ ఈస్ ద యూజ్ ఆఫ్ టెంప్లేట్ ఇన్ C++ లాంగ్వేజ్. ఓకే, ఆ కాన్సెప్ట్ ఎలా యూజ్ అవుతుందని చెప్పేస్తాను దీంట్లో. ఓకే, సో టూ HTML ఫైల్స్ తీసుకున్నాం కదా. సో వాట్ ఈస్ దట్? డెమో HTML అండ్ శాంపుల్ HTML. సో ఇన్ డెమో HTML, in HTML page, I have taken the common.css. So common.css ఉన్న extension file ని ఇక్కడ లింక్ చేశాను. ఓకే, link relation style sheet and href is equal to common.css. Okay, so in that HTML file, so this is another sample text here. So ఇది actually దేంట్లో ఉంది? div section hin. Okay, div section hin. So by taking the help of this div section hin, I'm writing I'm writing a code. I'm writing a CSS, cascading style sheets. CSS stands for cascading style sheets. We can write some styling codes to the HTML web pages. Okay, so HIN తీసుకొని నేను కలర్ యాక్వైజ్ చేశాను. ఓకే, టు ద సెంటెన్సెస్. ఓకే, దీంట్లో అనదర్ టెక్స్ట్ ఉంది, దీంట్లో అనదర్ టెక్స్ట్ ఉంది, బట్ both HTML files కి నేను కామన్ CSS ఫైల్ ఇచ్చాను. ఓకే, సో now we'll see the output of this HTML thing. Okay, now desktop. Yeah, desktop. Just a second. Sample text లో చూద్దాం, sample web page లో. Yeah, we got the output. So sample text లో, hi, this is sample text. Okay, now we'll see the demo. Okay, demo text form లో కూడా, so hi, another sample text. Okay, so both are in the same color, means I have given the same color, right? So ఇక్కడ చూద్దాం. So this is a CSS file. So same text sentences, sentences ఉంటాయి కదా, వాటికి నేను సేమ్ కలర్ ఇచ్చాను. కలర్ ఆక్వా. ఓకే, కలర్ ఆక్వా ఇచ్చేసి నేను బోత్ HTML ఫైల్స్ కి సేమ్ కలర్ ఇచ్చాను. ఓకే, sample.html కి అండ్ అట్ ద సేమ్ టైం demo.html కి సేమ్ కలర్ ఇచ్చాను. సో దట్ ఈస్ వై దోస్ బోత్ ఆర్ ఇన్ ది సేమ్ కలర్, సేమ్ ప్రాపర్టీ, సేమ్ ప్రాపర్టీ ఇచ్చాను కాబట్టి సేమ్ కలర్ లో ఉన్నాయి. సో ఇన్ ద సేమ్ వే, if you see here, So imagine this is as a CSS, okay, CSS, and this is as a HTML file, okay, HTML file అనుకుందాం. Okay, every time these HTML files are linked with this CSS file. Okay, దాంట్లో ఏది ఉంటే దానికి ప్రాపర్టీ ఏది ఉంటే that will be executed in the browser. So at the same time here also ఈ parameters, ఈ data types ఉన్నాయి కదా, these data types will be passed as a parameter to this template. Okay, ఈ template లోకి వెళ్ళిన తర్వాత it will execute the logic function present here. Okay, logic function that is present here. So in this way the C++, I mean template concepts will be implemented. Okay, so now we'll see the classification of these templates. So templates can be divided into two types. Okay, templates can be divided into two types, nothing but function templates and class templates. Okay, yeah, the concept of templates can be used in two ways, that is function templates and as well as class templates. Okay, so a function template is nothing but a generic function that represents the several functions performing same tasks but on different data types is called templates. In simple words లో చెప్పాలంటే function templates are nothing but special functions that have the ability to operate on generic data types. Okay, in C++ we can implement a template by taking template parameters. Okay, so we have the syntax for the function template, so we'll see it later. Next, a class template is nothing but it is also like a function template, but a class template is common, which contains some common class that can represent the various similar classes operating on the different data of different different types. Okay, so the syntax for the function template is this one. So template, template, just a second. Yeah, template class T1 and class T2. You may take single argument or multiple arguments, that's your wish. You can take one class, single argument or multiple arguments, and later here see, so this is the template keyword and this is the arguments. You can pass any arguments you want. Okay, so here template and class are the keywords and T2 are the T2 are the template arguments, and this T1 and T2 are the parameters. Okay, this whole is a argument. Okay, this whole thing is an argument. This is one argument, this is two argument. Okay, so here T1 and T2 are the parameters. Okay, parameters, and after this you can return type the function name and arguments of T2, T1 and T2. Okay, after that you can write the logic function, statements, whether it is if conditions or while conditions. Okay, so you can write any logic function you want. And in class template, so class T, a template of class T, you can also write the single or multiple arguments. That depends upon you whether it should be single or multiple. That depends upon you. I already told you this class is different from this class. Okay, this class body is different from this class. Here class is a keyword that is basically used in this template concept. Okay, but this class is different. This class contains some body, and in that body some public sections and variables declaration and passing the parameters. So here also we can pass the parameters in the class. Okay, like how we have declared the how we have declared the function, function templates, and how we pass the parameters into them. In the same way we can also pass the parameters in the class, parameters in the classes, and uh, we can solve the program. Okay, now so see, in this above declaration, T is a template argument, which is a placeholder for the different types of data types we use. We can also have multiple template arguments like T1 and T2 in this class template. Okay, so T is the placeholder name, which will be determined when the class is initialized, instantiated. We can define more than one generic data type using a comma separated list, and the t type can be used inside the class body. Okay, this is the syntax of the class template. Okay, now we'll see the function template example program and also the class template example program. So this is a example program on the function template to declare the greater number. So before we have done to find the smallest number, right? So we have taken the help of the function template to find the smallest number in the template example. Okay, so now we'll find the greater number. Okay, we'll find the greater number by using this template function template. Okay, so the same program, this is also same program, it is same program, but here we have used the concept that is another one. If n1 is and this is also same concept. Okay, same concept like template class t and t large, but here we have used a keyword called t large. Okay, the largest one should be printed out. Okay, should be printed out. So I hope you have understood the before example along under small. Here I have taken the smallest one, smallest value, but here I have taken the largest value. Okay, so let us see. Hash include IO stream, and next hash include stdio.h, and next hash include conio.h. If you give, you do not give, that's your wish. And using namespace std, and this is the function template. Okay, template class t, and in the t largest one, t n1 and t n2. So this t, all these t words are t letters are parameters. Okay, placeholders. We call them as placeholders. And if the n1 is greater than n2, then return the value of n1, and if the else return the value of n2. Okay, and we are declaring this template function template before the into main function. Okay, so we are declaring the different kinds of data types, and every time we'll pass these data types as a parameter to the template in order to find the logic function, in order to find the smallest or greatest value. Okay, we can, instead of using the if loops, you can also use while loops, do while loops, for loops, anything we can able to use in the templates. Okay, the main logic function should be present in the template concept. Okay, so now we'll execute here. We'll first of all we'll take the two integer values here, and we'll print them. Whatever the biggest value is, whatever the biggest value we get, that value will be printed out. And also we'll take two float values, whatever the two float values are greater, and which is one is greater, we'll print out that float value is greater. And we'll also take the character values, and whatever the char value is greater, that value will be printed out. So now we'll compile this. Yeah, now we'll execute. Enter two integer values, 10 and 20. So 20 is the largest one. Okay, so now here in this example we are declaring the largest one. Okay, we are declaring the largest one. Example, next 20.5, next 9.5. Which one is greater one? 20.5 is the larger one. Next, enter two characters, J and F. See, J is the largest one. Okay, so in such way we execute this function. This is just a function with the single argument. Okay, single argument. Now we'll write this function with the multiple arguments. Okay, now we'll see the function with the multiple arguments, right? So we'll take an example. Yeah, hash include IO stream dot h, next hash include on IO dot h, using namespace std. Now template class A, class B, class C. Okay, now the return type void show ax, sorry, py pz. Now cout slash n x is equal to, that is x, and later slash t, then y is equal to the value of y slash t, z is equal to, and the value of z. Yeah, completed. Now we'll declare the main function. Just show is nothing but display. Okay, then we'll pass different kinds of data types here. I mean different types of data type examples like a, and here I have taken 10, here 10.5, 10.3 or anything. Okay, next show here 10, next c, next 30. Okay, next show 20, 15, and the value z, just a key. Okay, now return 0. I'm just saving this function with multiple arguments. Just a second, there is an error here. Is equal to, sorry. Yeah, done. What happened? See, we have successfully printed the output here. Okay, so in the first case, the value of the x is a. Okay, so in the second case, the value of the see, in the second case, the value of the a is 10, right? In the second case, the value of the a is 10. In the third case, the value of the a is 30. Okay, so here if you see, so just a second, let me give the float type here. Okay, done. So in the first case, the value of the a is x is a, and the second the value of the x is 10. The value of the x is 20.4. So nothing but we have given the value out. I mean the value of x is equal to a character data type. Okay, next the character data. I mean the next replaced by the integer data type, and next it is replaced by the floating data type. Okay, so in this way we can pass the different kinds of data types to the templates to in order to get the output. Okay, so in the same way, in the same thing it happened to the y and z as well. Okay, so just a second, 15.5. Yeah, same thing. Okay, once a integer, once a character data type, once a floating data type. Here z also floating data type, integer data type, and character data type. Okay, so this will be the function with the multiple multiple arguments. Okay, so multiple arguments, nothing but here class a is taken, class b is taken, class c is taken. Okay, so in this way it will work, it will be working. Okay, so next we'll discuss about the classes. Okay, so yeah, let's see this one. Now we'll see the class template example program in order to understand the class class templates. Okay, now So here I have taken the student marks as an example for this class template total marks. So total marks of a student. So here header files, these are the header files, and using namespace std. And next we have a template with a single argument, and here we have the class with a class name called as student. Okay, and inside the class we have declared the t total. T is nothing but placeholder. Okay, marks 1 and marks 2, and we defines the public section here. Here is we will be using the student constructor. Okay, constructor, I hope you remember the concept of constructor. So constructor is nothing but which allocates some memory to the resources. Okay, so students is nothing but students t1 tm1 and tm2. Okay, every time whether it is an integer data type or float data type, the marks will be passed here. Okay, the marks 1 is nothing but m1 and marks 2 is nothing but m2. Okay, we have assigned these things. And t total marks, this is a function template. We use function templates inside the class templates as well in order to find it very easy, in order to make it very easy, and return the value of marks plus 1, marks 1 plus marks 2. So returning the total marks, I think. But here whether it is an integer or float data type, we'll be seeing the result total marks. Okay, total marks result. Okay, next in integer in main function, we'll see the student integer. Whether if it is integer, then just by default we are giving the values here. We are not taking the help of the user end. So creating the s1 object to store the integer data marks as a constructor, and in the second line I'm creating the s2 object to store the float data as a constructor. Okay, now we will be printing out total marks of the student. One is s1 dot total marks. Next creating the total marks of the student 2 is total marks of the student 1, but in float data type. Float data type. Okay, so we'll be running this program. See, so the total marks of the student 1 is 90. So we have given that 40 plus 50, right? 40 plus 50. So 40 plus 50 is nothing but marks 1 is 40 and marks 2 is 50. So every time this int will be passed to here. Okay, into marks 1 and into marks 2. Okay, here into mark 1 is nothing but 40, into marks 2 is nothing but 50. So 40 plus 50 is nothing but 90. Okay, we have got the integer value, that is 90. And next to float value, it will happen again and again. Okay, 4.2 and 343.3 is nothing but 347.5. Okay, it will give us the result. Okay, so this is the class example, class template example on this single argument. Okay, single argument. So now we'll see the class on multiple arguments. Okay, so this is also very easy, like function templates with the multiple arguments. So now we'll say we'll take the header files include iostream.h and conio.h. Now using namespace, this namespace std is very important. If you do not write this line, this is a key line. Okay, if you do not write this key line, you will be getting some errors. Okay, so now we'll declare the template and of class t1 and class t2. Okay, two arguments we have taken, multiple arguments. So class data that of public section data or data, that is t1 a and t2 b. So now here just see out /n a is equal to just print out a, and next b is equal to p is equal to print out b in the line. This is the class. Now main function, when it comes to main function, data int comma float, whether it is int or float, just print out h that is h value, which has 2 comma 2.5. Okay, now data int or character I, sorry, uh, I, that is 15, sorry, 19, anything you take, either C or A, B, anything, any character value. Next, int, just take, instead of int, just take float and character, or you can also take int. Now, just to take J, and next 3.1.23, comma, 20. So second, 20. So just return the value. Okay. Yeah, class templates with the multiple arguments. See, a value, a value is equal to 2. Here we have given 2 integer value, and next b value as 2.5, the float value. Okay, so every time the value will be comparing, the passing the data type as a parameter. So this is the main concept you need to understand. And a value in the second case is 19, and b value in the second case is c, that is a char data type. And you can also give space in between of them to understand it very better. Just a second. So in this way it will be working. So just a second. So the result will be just a second. We'll be giving it here. We'll be giving it here. Just a second. Okay. To take out this. So a value is 2 and b value is 2.5 in the first case, and a value is 19 and c value is character, and the d value is 1.23, floating point, and b value is 20. So in this way, class templates with the multiple arguments working. Okay, so this is an example program for that, and we'll be coming to the main last topic, that is stack data structure. Okay, stack data structure by using the class template. Okay, by using the class template. So yeah, this is a concept here. So we need to understand the class data structure. Okay, class data structure before uh, understanding about the understanding by using the class templates. So what is meant by stack? So so stack is nothing but it is a linear data structure. Okay, so stack is nothing but it is a linear data structure which stores the information. Okay, so information, it majorly contains two operations called push and pop operations. So to check even even to push the elements or to pop the elements, to perform these operations, there will be some certain conditions we need to check. Whether to push the elements, we need to check whether the stack is empty or not. Okay, if the stack size is exceeded, if the stack size is filled, we can't able to enter the elements. Okay, so in order to do the pop operation, we need to check whether the stack is empty or not. Okay, if the stack size is empty, we can't able to pop out any element. Okay, if there is no element present in the stack, we can't able to pop out anything, right? So we need to check whether the stack is empty or not. So we need to check all these things. Okay, so we should perform it line by line. Okay, line by line, in order to execute this kind of stack data structure operations. Okay, so it follows the order of last in first out. Okay, last in first out. It is a kind of thing. Okay, it follows the order of last in first out. When it comes to queues, it follows the first in when it follows the order of first in first out. Okay, this stack data structure, it follows the order of last in first out, or else it is also called as first in last out. Okay, so uh, in order to check Okay, first of all, I'll be checking whether the stack is empty or not before inserting any values. So to check the condition, I mean to check whether the stack is full or not, we need to check the condition. If, for example, if top is equal to max, so then see out that the stack is full. Else, just increment the top and put that element. I mean, a is equal to a top is equal to element. Okay, or else after that, after that. The after if you see the stack is not equal to empty. Okay, if the stack is if the stack is not full, you can you can increment the value of the top, and you can put, you can insert the values. Okay, so in this way push operation will be working. So if you want to perform the pop operation or its pop function, you just need to check whether the condition, if the top is equal to -1, or else if the top is less than 0. Okay, if the top is less than 0, then you need to print out the stack is empty. Else, just to see out decrement the top. Okay, decrement the top, and just delete the element which is present at the top level. Okay, so we'll understand the class data structure. So these are the two main operations. So these are the two main operations in the stack linear data structure. So stack is the example for the linear data structure in order to store the information. Okay, so push is nothing but insertion, and pop is nothing but deletion of element from the stack. So these are the main thing here. So now, so we'll understand. It is getting late. The video is getting lengthy. So we'll be explaining this program. So hash include iostream.h. This contains the main keywords called C and C word. And next, here I have taken only one template, that is template class T, with a single argument. So now here I'm creating a class stack, and within this class stack, I'm taking the template parameter here. Template parameter, every time I can pass the, if I want to pass the integer values, I can pass the integer values in this stack. If I want to pass the float values, I can pass the float values into the stack. If I want to pass the character values, I can pass the character values into the stack. Okay, so declaring the stack size of 10. Okay, if you want to take any like 100 also, you can, if you, that's your wish. If you want to take, you can take. Okay, so next, because I have given t value, okay, because of giving this t value, I can pass any data type to this stack. If I want to, if t is taken as an integer, I can push the integer values, and if t is taken as a float values, I can pass the float values. Okay, so now integer into top. Okay, so these are basic words before if you're declaring the stack. Okay, stack size. So I'm taking the stack as a constructor. Okay, this stack as a constructor, so which performs a memory allocation to the stack resources like top and, okay, so in the public section I'm declaring all these things. Okay, so top is pointing towards to the -1. Okay, always top should be pointing towards to the -1, so that we could compare the top to any other thing in order to perform the push and pop operation by checking some conditions like top is equal to -1, then print out that stack is empty. Okay, if top is equal to n. Okay, if top is equal to 1, okay, or else top is equal to n, then just to print out the stack is stack is can't insert the values in the stack because stack is not empty. Okay, so in such way we can use this kind of top thing. Okay, in order to check those conditions. Now see out, enter the stack size. Okay, so if everything is fine, we need to ask the user to enter the stack size, whether it is integer data type or floated data type. We just don't need that thing here. We are asking the user in order to enter the stack size here. That will be read out as a n with the letter n. Now, so this is the push operation function. Operation function. So void push, just a t is a parameter here. Okay, t is a parameter, and element. Okay, passing element is nothing but it is passing like an argument. Okay, so if I want to insert the element of each data type while passing it as a parameter, now I have to check this condition whether top is equal to n-1. So if the top is n-1, whatever the values we take will be less than or else equal to the n value. If the value will be greater than the top, then increment the top, okay, and then increment the top, and just top, yes, top is equal to put that value, okay, put that element, okay, the element should be inserted into the top thing, okay, top place, okay, else the stack is full, then cannot insert the new element, okay, you need to declare that. So now after this push operation, now you need to declare the pop function, okay, pop function. So if the element is if the stack size is not empty, okay, if there are some elements present in the stack, then we need, if we want to perform the pop operation, then you actually need to check the condition whether the stack is empty or not, whether the stack contains elements or not. So in order to do that, in order to find that, we actually require the top keyword top. If the top is less than zero, okay, if the top is less than zero, then we need to declare that, stack size is empty, okay, or else if the top is greater than zero, it says that some elements are present, that elements are present. So now we need to pop out that element, right? So just to pop out the element, whatever the element present at the top top place, just to just to pop that element s top, okay. So s top is nothing but just to top the element of the stack size, stack greater size, stack I mean whatever the element which is present at the high, okay, high value, I mean high place, just to pop out that element and decrement the popped element, okay, then decrement the top value, okay, every time this pop operation will be performing. If you want to perform the pop operation again and again, okay, to decrement we have to decrement the top value, okay. Next, I'm taking the member function here, that is void stk operation, okay. So I'm taking the stk operation, okay. So now we use this after this we use this template, again we use this template and class of t, okay. Next, void stack of this t and stk, with the help of scope resolution we use this stk operation, okay. We can perform it. See, uh, if we want to use a stack operation outside a member, this is a member function. If you want to use it outside, then we have to use one template again and declare it by using scope resolution, okay. So next, later int choice is equal to 1, okay, int choice is equal to 1. And next, I, this I will be used in the for loops in order to declare the output of after the push operation and pop operation, okay. Next, t and element, okay, t and element. So while choice is equal to less than 0, I mean greater than 0, and choice is equal to less, I mean choice is less than 3, then I'll be taking all these things as a menu, okay. For menu purpose, I'm taking all these things. Just a second. Yeah. So see out, first of all, push value, I mean push, and second one pop, okay. If I have taken some integer stack data size as 10, okay. So next, it will be displaying the two operations, whether I have to insert the value, or whether if you want me to pop the values, I will be popping out. So it will be asking us to enter the choice, okay. If our choice is 1, if our choice is 1, so then it will be moving into the first case, that is push operation, okay. So this case 1 will be for push operation, and after the case 1 completion, next it will be performing the pop operation, okay. So the user can select whatever the operation he wants to do, okay. If he wants to perform push operation, then he will be entering by using the switch case, he'll be entering into the case 1, okay. So it will ask us, whatever the element that you want to push, just enter it here, and with the help of ELT, we'll be reading out the value, and next we'll be putting that element in the stack, okay, by using this push function, okay. So now we'll be reading out those, I mean printing out the values by using this for loop, okay. See out the stack contents after push operation are, for I is equal to 0, I mean we are reading out, I mean yes of I, whatever the elements, yes of I mean stack size, whatever the elements that is present in the stack will be printed out here, okay. For I is equal to 0, I is less than or equal to top, then increment the top, and I mean increment the I value and just see out, I mean print out the stack elements. Okay, next to break the condition here. Next, if he wants to, I mean if the user wants to pop the operations, I mean if he wants to pop out the elements present in the stack, then he needs to check the condition, I mean then he needs to check whether the elements are present or not. So if top is less than 0, then else enter the stack size is empty. Okay, else just decrement the top every time, and then just perform the pop operation. Okay, just to perform the pop operation. Okay, this will be happening here. See, pop function by using with the help of pop function. Okay, so pop function is nothing but it will again go here. It will again go here, and every time it will be performing this operation. Okay, so after popping out the stack contents after popping out operation are for I is equal to 0 and I is equal to less than or equal to top, then increment the I, and yes, C out is equal to S of I. This is for just for displaying the elements in the stack size. I mean elements in the stack after popping out after pop out operation. Okay. So next break we'll terminate this process by writing this break condition. Okay, I mean break keyword. Next, default exit 0. If the user do not want to perform any operation, then by default he'll be I mean he can exit out. Okay, next this main function. Okay, when it comes to the main function, this is just for the menu purpose. Okay, so if you want to insert the into data type, then just stack size of int and STK. Okay, if you want to insert the float data type and stack size of STK. Okay, STK2. Okay, just a second. Yeah. Now while one means nothing but every time this condition will be true. Okay, it will be by default entering into this while condition. Okay, enter the choice. So if I want to enter the stack size as stack size of 10, then I need to enter right. Okay, then I need to move into one condition, right? Okay, so that is why I'm using this while condition. Okay, so I want to enter the choice here. So I want to enter the choice, like for example, I want to enter the interstack data type, interstack size, and if I want to enter the float stack size, then I want to enter some number, right? So I have to take either it is 1 or 2. Okay, so here stk1 dot this member function and stk dot this member function. Okay, then just to break the statements, and by default just if the user do not want to select anything, just exit by default. Okay, so I'll be compiling this program now. Let us see the output. Okay, so enter the stack size. So here it will be asking us to uh, enter the stack size of the int type data. Okay, you can give how much you want, but I'm giving 10 here. So it will asking us by default, it will be asking us the float type data. Here also I want to give, for example, if I want to give 5, I just want to give, I'm declaring as 5. So it will be asking us to perform the operation either on int stack data or float stack data. But here I want to perform this operation on int stack. Okay, here I'll be performing the operation on int stack. So first one I'll be selecting. So in after that I'll be asking us to perform whether push or pop operation. So by default, there are no elements are present in the stack, right? So I want to perform push operation. Okay, first one I will be selecting. Now enter the element that you want to push. Okay, it will be asking us to enter the elements. Okay, first of all I'll be entering 10. Okay, see it will be displaying this output. Stack contents after push operation are 10. Okay, so now I want to perform the push operation. Now this time I'll be giving the element 20. Okay, so the stack contents after the push operation are 10 comma 20. 10, I mean 10 and 20. Now again I want to perform the push operation. This time I will be entering 30. Okay, and next again I want to perform the push operation. This time I will be entering 40, and again I want to perform the push operation, and again I will be entering 50. See, the stack contents after push operation are 10, 20, 30, 40. Okay, so these many elements are present in the stack right now. I mean these all are the integer data types. So if I give some kind of float data type, it will not be accepting. Okay, because here the very first I have entered my choice, that is of into stack data type. Okay, so now I hope you have understood. You can take either integer data type or a float data type in the beginning itself. Okay, while you're while you're preferring the options. Okay, now I want to pop the operation. Now after popping out, see the popped element is, as I already told you, whatever the element that is entered last, that will be the popped element. That will be the first popped out element. Okay, so after popping out 50, the elements present in the stack are 10, 20, 30, and 40. If I want to perform the pop operation again, see the last element, that is 40, will be popped out. So now the remaining elements are 10, 20, 30, 40. Okay, so now I want to exit. Just enter any key, that will be exited, that from the program. So I hope you have understood. Now I'll be taking the float data type for example. Okay, let us take the example. So I have taken the 20. So now we'll take the push operation. Okay, first of all, we'll take the push operation. I'm entering the uh, yeah, entering the element 10.5 first, and again I want to push the element that is 20.5. See, after performing the push operation, the elements present in the stack are 10.5 and 20.5. So if I want to perform the pop operation, I just enter the option 2, and now the elements after the pop operation are 10.5. So in this way, the stack data structures will be working. So this is the class about templates. So I hope you have understood. I'll be giving the programs in the description below. You can go there and you can copy them and you can paste them and you can work them. You can work on them. Okay. Thanks for watching this video.